Okay, so looking at problem 14, the difference between this problem and the previous problems is we don't have a 0 on one side of the equation by itself. We have a 3 here. So actually what we need to do is get a 0 by itself on one side of this inequality. I'm going to do that by subtracting 3 from both sides. And actually we should leave a little bit of space here, because what we'd like to do is combine these two terms together. This term has a denominator of x minus 12. This one doesn't have a denominator. So we're going to give it a denominator of x minus 12. That would be completely illegal unless we gave this a numerator of x minus 12 as well. So basically what we're doing is we're just finding a common denominator for these two terms. Now let's write this out. Our denominator on both terms is now going to be x minus 12, and we can combine these two terms together. The first term gives us an x plus 5. The second term gives us a negative 3 times that quantity x minus 12. Now if we distribute this negative 3 through the parentheses and we combine like terms, now we're in a position where we can start asking the question, what are our critical values? And again, we find our critical values by setting the numerator equal to 0 and setting the denominator equal to 0. Setting the denominator equal to 0 gives us x equals 12 as a critical value. Setting the numerator equal to 0 gives us x equals 41 over 2 as our other critical value. And you can see that I already typed those into the solution up here. Now again, if you want to know more about critical values, you can watch the whole lecture on this. What I'm going to do is just tell you to graph this function. Take a look at the graph of the function. And in this example, the function that we're graphing is actually this one down here, because we want to know where is that function greater than 0. And that's what the function looks like. Now, as you might expect, this does have a vertical asymptote at x equals 12. You'll also notice that this graph has a 0 right here. And that 0 happens at the other critical value, 41 halves, or I guess that's 20.5. Okay, now to answer the question, we need to point out where this graph is greater than or equal to 0. That would be, where is this graph above the x-axis? That is a terrible picture, but hopefully it demonstrates where this graph is greater than or equal to 0. You'll notice everywhere else on this graph is below the x-axis, so this is our only interval. And this interval is going to go from 12 all the way up to the value of this 0, or the other critical point, which is 41 halves. Again, if you want a different technique for doing this, you can watch the lectures, and they give a very different way to do this problem. I prefer to just look at a graph and get the answers that way, but there are certainly other ways to do this. Okay, bringing the problem back up, we got a solution of 12 to 41 halves, and I put a parenthesis there, but I don't think it should be a parenthesis, because we had an equal sign in our inequality. We were essentially asking, where is this equation both equal to 0 and where is it greater than 0? So we're going to include this 41 halves point right here in our final answer. We're not going to include the 12 in our answer, again, because that x equals 12 is a vertical asymptote, and the function never touches x equals 12. So I'm going to enter the solution in here, and that looks pretty good. Now that is how we're going to do the rest of these problems for this entire section. So you'll notice that this one is the ugliest problem of them all, so why don't we try this one together? Okay, there it is. That is the inequality that we are trying to solve for x. Now again, this is just a rational function, and you'll notice that one of the first problems you see is that we don't have a 0 on one side of this inequality. I would like a 0 on this side of the inequality. So what I'm going to do is I'm going to bring that term on the right over to the left side. Now, if we're going to have any luck with combining these rational functions, we're going to need to find a common denominator. And to me, that means we need to start by factoring. And at this point, you'll notice that we have 3 different factors in our denominators. If we want to find a common denominator for all 3 of these terms, well, we're just going to have to multiply this first term by x minus 7, this second term by x minus 1, and this third term by x plus 7. If we do that, we're going to get the same denominator on all 3 terms. Now, the numerators are going to look pretty messy at first. Fortunately, we can combine them by distributing and combining like terms. Okay, so I distributed. Let's combine all of our like terms together. And And now we can start asking the question, what are the critical values of this rational function? Unfortunately, I don't know how to factor the numerator, so to find the critical values up here, we just have to set that numerator equal to 0. And unfortunately what that means is we're just going to have to use the quadratic formula. Now, doing a little bit of work in the background and using my good friend Wolfram Alpha here to confirm my answer, I am getting that the critical values for the numerator are -9 plus or minus the square root of 78. Okay, so that is a terrible mess, but we also need critical values for the denominator. Fortunately, those are going to be much easier. Set that denominator equal to 0, and you're going to get x equals -7, x equals +7, and x equals 1. And if you enter these answers into my math lab, there they are. Those are the critical values. We have 5 of them total, 3 here and 2 here. Now, in order to get a solution set, I am going to graph this function right here, and I'm going to take a look at where that function is less than or equal to 0. So I'm going to go over to Desmos to do that. So using Desmos, we get a pretty bad looking graph. As expected, there it is. Now let's pick out our critical values off of this graph. Somewhere over here we have a 0, and that 0 is -9 minus the square root of 78. Somewhere in here we have a 0, and that 0 is -9 plus the square root of 78. And we have 3 vertical asymptotes. One vertical asymptote at -7, one vertical asymptote at +7, and one vertical asymptote at x equals +1. And now to answer this question, we need to go back to this inequality and ask, where is this function less than or equal to 0? Well, I'm going to start tracing out all of the points on this function where the graph is below the x-axis. We're below the x-axis here, and we're below the x-axis over here. So it looks like there are 3 intervals where our function is below or equal to the x-axis. One, from -9 minus the square root of 78 all the way up to this vertical asymptote of x equals -7. The second interval is over here, from -9 plus the square root of 78 all the way up to the vertical asymptote of x equals 1. And the last interval is going to be over here. That's from x equals 7 all the way up to infinity. So this is going to be our final answer. I'm going to double check brackets versus parentheses. We have an equal sign in our inequality. Therefore, wherever this graph touches the x-axis, it is going to be part of our solution. So we have a bracket here at this 0, and we have a bracket here at this 0. However, the graphs never touch vertical asymptotes, so we're going to have parentheses at -7, parentheses at 1, parentheses at 7. And okay, I am going to bring up my math lab, and I'm going to type this solution in. It's only going to take me 7 minutes to type this in. And there it is. I have it typed. I'm going to enter that answer. And oh my gosh, it was right. I'm going to call it there because that problem took a really long time to do. Let me know if you have questions about any of the other